Layer 1. Physical layer. The physical layer is all about bits and hardware, the raw mechanics of data moving from one device to another. Think of it like the road network. Cables, switches, network interface cards, radio waves for Wi-Fi, and electrical signals are all under this layer's domain. It defines how bits translate into voltages, light pulses, or radio frequencies. Your computer sends data through a Cat6 cable. The physical layer converts digital bits into electrical pulses, pushes them down the cable, and ensures timing stays tight so the receiving device interprets signals correctly. You've experienced it if you've had trouble with a frayed Ethernet cable or spotty Wi-Fi. Those issues are problems at this layer. That means whenever a technician checks your wiring or adjusts your router antenna, they're dealing with layer 1, making sure the roads are clear and signals are sent reliably. Layer 2. Data link layer. Layer 2 takes raw bits from the physical layer and organizes them into frames, complete units that include error detection and sender/receiver addresses. It splits into two logical parts, the media access control sublayer and the logical link control sublayer. MAC handles physical addressing using MAC addresses, while LLC tags each frame so the correct network protocol, like IP, gets handled on the receiving side. In a busy apartment building, MAC is like your apartment number, so packages go to you, and LLC is the apartment's internal mail system that knows which service, e.g., Quix, Grubhub, is addressed. Protocol examples include Ethernet, wired, and Wi-Fi wireless. Layer 2 also manages collision detection, like avoiding package pileups, and corrects simple errors using checksums or parity bits. When you connect multiple devices to a switch or set up MAC filtering on your Wi-Fi router, you're operating at this level. Layer 3. Network layer. The network layer handles the routing and logical addressing of data, making sure packets travel through multiple networks to reach their destination. Devices use IP addresses to identify endpoints. This layer determines the optimal path for data via routers, much like choosing the best route on Google Maps. Example, when you send an email, it's broken into packets and each carries metadata, including source and destination IPs. Routers examine these headers and guide each packet across networks via the fastest or least congested route. Protocols here include IP, ICMP, used by tools like ping and traceroute, and routing protocols such as OSPF or BGP for bigger networks. So the network layer is like a postal system that not only labels where packages should go, but also figures out the routes across multiple towns. Without it, your data wouldn't find a way across the internet. Layer 4. Transport layer. The transport layer is the traffic controller of data, ensuring reliable delivery, proper sequencing, and error recovery between devices. Think of it like the Postal Service checking that packages arrive intact, in order, and without loss. This layer offers two main protocols: TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. TCP is connection-oriented. It sets up a communication link, checks packets for errors, and resends lost ones. This is why websites, emails, and file transfers rely on TCP. Accuracy matters. UDP, by contrast, is connectionless and faster but less reliable. It's used for live streaming, online gaming, or VoIP calls where speed matters more than perfect accuracy. The transport layer also manages port numbers. Think of these as doorways to specific services or applications on a computer, like HTTP on port 80. When you type a website address, TCP or UDP makes sure the data reaches the right room on your device. In short, Layer 4 keeps communication smooth and efficient, balancing speed and reliability based on the task. Layer 5. Session layer. The session layer manages connections between devices, establishing, maintaining, and terminating communication sessions. Picture it as the meeting organizer that sets up, monitors, and ends conversations between two parties. For example, when you log into a website, Layer 5 keeps your session active so you don't have to repeatedly authenticate while browsing multiple pages. It handles dialogue control, deciding who speaks when, and synchronization, inserting checkpoints or recovery points in data streams. Protocols like NetBIOS and RPC, remote procedure call, work at this layer. Additionally, Layer 5 supports full duplex or half-duplex communication modes, deciding whether both devices talk simultaneously or take turns. In practical terms, it ensures that complex interactions, such as a video conference or file transfer session, stay organized and synchronized until properly closed. Layer 6. Presentation layer. The presentation layer acts as the translator and formatter of data. It makes sure information sent from one device is understandable by the receiving device, no matter the differences in data representation. Think of it as converting a book written in one language into another, so anyone can read it. This layer handles data encryption and decryption, ensuring your information stays secure during transmission. For example, when you access a secure website, HTTPS, the encryption process happens here. It also deals with data compression, shrinking large files for faster transfer, like zipping a folder before emailing it. Common formats managed at this layer include JPEG for images, MPEG for video, and ASCII for text. Layer 6 prepares data so that the application layer can present it correctly and efficiently. For example, When you watch a video on YouTube, the presentation layer decompresses the video stream and decodes it into a format your device understands, while also handling any encryption to keep the content secure. Layer 7. Application layer. The application layer is the closest to the end user and interacts directly with software applications you use daily. It provides the services and interfaces that let you browse the web, send emails, or transfer files. This layer includes familiar protocols like HTTP for websites, FTP file transfers, SMTP, email, and DNS domain name resolution. When you type a URL in your browser, Layer 7 kicks in to request the web page and display it. Unlike other layers, the application layer doesn't handle how data is transmitted, but focuses on providing network services tailored to user needs. It's the front desk of the OSI model, connecting your applications to the network. Sending an email with Gmail involves the application layer using SMTP to send your message, while the rest of the OSI layers handle how the data moves behind the scenes.